So what we learned last time was how to find a line that best goes through almost all the points equally. So for example, what we did in 6.4b was we figured out how to mathematically figure what this line of best fit is called. It was called a linear regression. The regression was a mathematical equation that we punch in the calculator. It performs the calculation to find the best slope, the best y-intercept that would go through all those points. It's a mathematical calculation that you do not need to know what happens inside that calculator when it happens, unless you wanted to go into AP Stats. So what we're doing now is we're going to actually measure how far are each of the individual points away from that line of best fit. I'm going to pretend, like let's say we had a dot. I'm going to put one extra dot kind of high right there. And I'm going to make a little bit of an arrow here, kind of like a little thing. The distance from the dot, from that point to our line of best fit is called the residual. The residual can be above the line. It could also be below the line. I'll draw one more down here. There's lots of residuals on this particular graph. How far away are each of those points away from that line of best fit that we found last time? That's what a residual is. If we were to write down what a residual is, this is what I would write down. Residual. It is the measurement above or below the trend line. I'm going to underline the residual because I'm defining it for you. The residual is the measurement above or below the trend line. So what you're going to have to do today is you're going to have to figure out what the residuals are. And you're going to be given things. So I'm going to start you off on number one. This will be one of the first times I only do half of a problem for you, because I want you to do the rest of the problem. Okay, so this is number one on your worksheet. Number one looks like this. There's an X column. There's a Y column. There's a predicted column. Predicted value. Let me make sure I'm spelling this correctly. I'm not spelling it correctly. Predicted value. And then there's the residual value. Residual value. I'm going to zoom in just a little bit. Move this up a little bit too. So we have a predicted value, a residual val. My U's and V's look very similar to each other. I'm going to eventually type this up, but it won't be for your class. It'll probably be for next year's class, so I'm sorry. You guys get the handwritten year. I'm sorry. This is how it goes. And so for number one, they're going to give us a bunch of values. And I'm only going to write down 3 of them. 5, 10, 15. The Y values they're going to give us 3, 4, 9. And then everything else is blank. They also give you a linear regression equation. And I'm going to write that right here. Linear regression equation is y equals 0.5x. Okay? Let's Just want to make sure that I know that this is part of the bottom here. This is this part. I'm not doing a very good job with staying organized. Should have went down one more line. There we go. It'll be like that. My linear regression equation for number 1 is right here, and I put it above my predicted value. Y equals 0.5x. So the first thing that you're going to have to figure out is what's the predicted value. Okay? The predicted value here is when you plug in x. So right below here, this is what I'm going to do. I'm going to write down what I do for this particular piece. This is where I plug in x into the regression equation. Plug in x into the regression equation. Bless you. We're plugging in x into the regression equation to get this predicted value. Here's what we're doing. We are going to take this x right here, this 5, if that's what x is, and I go and I plug it in here, what do I get for my y value? 0.5 times 5. What's my predicted value? You could do that on your calculators. 0.5 times 5, right? If you're in the stats menu, you can still perform this calculation as long as you press the times button right there. You can also get out of the stats button if you don't want to. So, what's my predicted value? 2.5. How did I get it? I got it by doing, I'm just going to write down what my work was. It was y equals 0.5 times 5. I'm just going to write that there because that's what I did. You're not going to have to show me that. You're just going to do it, and I'll be fine with it. So the next number that I'm going to get, I need to take this x, the next x, and plug it in. And I bet you some of you can do that in your head. 0.5 times 10. What's it going to be? Good. And then the next one, I cannot do in my head.
7.5.
Oh, you guys are awesome. You guys are smarter than Mr. Paramo. See? So you found all the predicted values. The predicted is we're going to plug something in and find out what it would be on the line at that x value. Now what we're going to do is figure out the residual. And the residual, like I told you, is how far are these points away from this actual line. Like this is what would be on that trend line, and I want to know how far away it actually is from the trend line. So what we do for residual values, let's write down what we're going to do for residuals. Residual values, we do the y value subtracted by the predicted value. Predicted value. When you're a math teacher, you end up really not losing your spelling. I'm totally not good at spelling anymore because all I do is numbers. So I always have to double check. And there's no spell checker when you're writing things down. Okay, so I'm doing the y value subtracted by the predicted value. The y value subtracted by the predicted value. I always do the y value first, subtracted by the predicted value. Do you know what 3 minus 2.5 is?
0.5.
That is correct. Do you know what 4 minus 5 is?
-1.
You do. It is possible to have negative residuals. What does that mean? It means it's below that trend line. Do you know what 9 minus 7.5 is?
2.5.
Not 2.5. 1.5. If you want to double check, you can double check on your calculator. So this is what you're going to do. You are going to fill in a table that was already pre-constructed. You were given this information. You have to find the predicted values. You have to find the residual values. And this is how you're going to do it with these two bits of information. And then, when you're done with that, you will actually have to graph these things. When you go to graph these things, what you're going to do when we go to graph, now I'm going to put graph right here. Scoot this up a little bit. When we go to graph, really this is what it's going to look like. There's going to be this other piece that's way over here that we're not going to use. We're just going to use this piece to the right. We're going to use the piece up and the piece down. And we're going to label some numbers here, okay? When we go to plot these points, we have to look at our x values. I'm going to go back to this chart and kind of point it out to you. Do you see what we're counting by with our x's?
Yes.
That's what we should count by on our x-axis over here. We should count by 5s. Now, I'm not going to count this one as 5. I'm just going to go 5, 10, 15 just for right now because I have the room. When you're doing yours, considering you're going to have 5, 10, 15, 20, 25, 30 for your graph, you might go every line. That's what I'm thinking you'll do. And what we have to do is we look at these residual values and we see how far away is it. Okay? You might end up going up to -3 and or down to -3 and up to +3. So I would label these as 1, 2, 3 in the positive direction. -1, -2, -3 in the other direction. So when you go to plot these, what you're doing is you're using the same x, but instead of the y, you're using the residual value. This is like your y value. Your residual value is the y coordinate. This is your x coordinate. I'll show you what I mean. Instead of this x and this y, I'm going to use this x and the residual. How far above the line is it? 5.5. So I go over here to 5. And I need to put a dot at 0.5. I'm going to make it kind of big so you can see it. I'm not quite at 1. I'm at 0.5. You see how that works? I'm 0.5. I'm halfway up to 1. Which means when I go to 10, what's the y coordinate I'm going to use? I'm going to use... So I go 10, -1, and I make my dot there. This one actually covers up the 10, doesn't it? For me. It might be different on yours. And 15, what's our residual? And that's how we're going to graph. We're going to graph by plotting x's and how far away are these from the graph. What you can think of, if I were to go back up to this original drawing, if I'm doing a residual plot, which is what we're doing down here, what we're doing is basically making a graph, turn sideways and going how far away is it, and we're plotting it along the x-axis. This is how far away it is. This is how far away it is. This is how far away it is. Okay? That's what we do, and this is called a residual plot. I'm going to put that right next to this. Residual plot. That's what this graph is called. the last thing that we have to really understand, besides these two concepts, is how do we know if a residual plot, why are we doing it? It's because it lets us know whether the line that we have, is it a good fit or is it not a good fit? Okay? Here's what I want you to know about residual plots. I'm going to write down residual plots. Can tell us if the equation is a good fit. Can tell us if an equation is a good fit. I gotta move that up a little bit. So you have two choices: good fit or not a good fit. I'm going to write down both. There's a good fit type of residual plot, and then there's not a good fit type of residual plot. It is a good fit when the pattern looks random. It's a good fit when the pattern looks random. Balanced. Those are the words that I kind of think of when I think about it being a good fit. It is not a good fit if it makes, not a good fit if it makes a shape So sometimes you're going to be getting these residual plots and you're going to have to make a decision. I'm going to give you 3 examples and then we'll be done. And these are very easy to do. Here's my first residual example. Here's my second residual example. He'll be my third residual example. You might end up getting a graph that looks like this. You might get a graph that looks like this. You might get a graph, a residual that looks like this. If it makes a shape or a pattern to it, if it's not random, then it's not a good fit. So here's my question to you. This is a residual plot. Is the equation, is the linear regression equation, is it a good fit or is it not a good fit? What do you think? It's a good fit. This pattern looks random to me. There's some above, there's some below. Doesn't look like it's making any specific pattern. It's a good fit. The second one. It is not a good fit. It looks to me like it's a quadratic, like something else would have been a better regression equation. The last one, good fit or not a good fit? Not a good fit. Good job. That's where we're going to end our notes today.